So in this video, we're going to review adding and subtracting rational numbers. First, a rational number is any number that can be written as a fraction. And so if you look at the number 5, we can rewrite that as 5 over 1, so this is a rational number. The number 6.2 can be written as 6 2/10, which can also be written as 62/10, which is a fraction. So really, if you can write a number into a mixed number, that's also considered a rational number because we know we can always convert a mixed number into an improper fraction. Okay, so what would not be a rational number? Pi is a number that we can't write as a fraction. Square root of 2 would be a number that we cannot write as a fraction. And so what you're going to find is adding and subtracting rational numbers means we're going to be adding integers, which are your positive and negative whole numbers including 0, and decimal values, and mixed numbers or improper fractions. And so our goal will always be to add like terms. So if you have a problem with fractions and decimals, we're going to decide, is it better to convert into decimals or is it better to convert into a fraction? So here's our first problem. So at this point, I want you to write down the problem and try to solve it on your own. Okay, so here I go. At this point, you should have your solution. Let's check with mine. So, the answer to this question is 16 and a half. And so if you have that answer, you can fast forward to example number 2. If you don't have that answer, let's go through all the steps. My steps might look a little bit different than yours, so instead of erasing your problem, follow along to the right or on another sheet of paper. The first thing I'm going to do is notice that everything's already in mixed numbers, and so this is an easy one for us. We're going to keep everything as fractions. First, I'm going to decompose my mixed numbers here. This one will be 4 2/3. And then this one here would be 5 5/6. And when we say that and, that's our way of adding the fractional part. So now I'm just going to rewrite this whole problem as 6 plus 4 plus 2/3, and then plus 5 5/6. I'm going to use the commutative property to move my values around, and so kind of like we were talking, combining or getting our like terms together, I'm going to move all of my integers or whole numbers together. And so I'm going to have 6 plus 4 plus 5 all together, and then I'm going to combine my positive 2/3 and positive 5/6 together. Okay. My whole number, 6 plus 4 plus 5 makes 15. So this piece here gives me 15. And then this is where I would need to get a common denominator. And so to add my fraction pieces together, I need to multiply by 2 because that would give me 6. So this is actually an easy one to get a common denominator for. So 2 times 2 makes 4 out of 6 plus 5/6. So I rewrote my whole entire problem. Now I'm going to be adding together my fractional pieces. And so this problem gets us 15 plus, and this is 9/6. So common denominator means we keep it common when we add, and then we just add the numerator. And then to get my final answer, I'm going to, there's 2 different ways to do this final answer, and I actually am going to show you both ways, okay? So you can pick which way you like. First way is to just get a common denominator between them. Meaning, I would take this one and multiply it by 6 because the denominator, and I should have done that first, The denominator is 1. If I multiply 1 by 6, I get this common denominator of 6. So 15 times 6 is 90, divided by 6, plus 9 divided by 6. And so I end up with 99 divided by 6. This is considered an answer. It is correct, but if you wanted to simplify the answer, you could divide the numerator by 3 and the denominator by 3. And so I end up with 33 over 2, or 33 halves. So that's another answer. And then if you wanted to convert to a mixed value, the mixed value would be how many groups of 2 fit into 33. It'd be 16 groups of 2, which makes 32, and there's one number left out of the 2s. Let's see. I probably didn't say that very well, but when you convert from improper to mixed, you want to look at groups of this number down here. Now, the other method, which I'll do in black here, the other method would be to leave the 15 alone and just convert 9/6. So 9/6 would be how many groups of 6 are in 9? One group of 6. How many are left over? 3, 6. And then from there, we even could simplify 3/6 to 1 and 1/2. Then we can use decomposition of this fraction to then give us 16 and 1/2. Okay, so the answer either way is going to be 16 and 1/2. Next problem. So 6.2 plus 4 1/3. So same thing, try the problem, press pause, and then press play when you are ready. So the answer to this problem becomes 10 and 8/15. So same thing, if you got this one correct, go ahead and move on. And fast forward to example 3, I guess. All right, otherwise, let's look at the problem. We have 6.2 and 4 1/3. One of them is a decimal, one of them is a fraction. And so you look at the fraction and say, can I convert 1/3 into a decimal? And you cannot. 0.3 or 0.33 will not be sufficient. It will not be accurate, and you will end up with an incorrect answer. So this would be a problem that we'd have to convert the whole problem into a fraction. So how do I convert into a fraction? This piece here is 6 and 2/10. Okay? I can simplify my 2/10 by dividing the numerator and the denominator by 2, and I end up with 6 and 1/5. And then now I have 4 1/3. So same as before. I'm going to decompose my fractions. I am going to regroup or use the commutative property to start by moving my terms around so that I can get my 6 and 4 together, and then I'll get my 1/5 and 1/3 together. This piece here gives me 10. And that's my easy part. And then 1/5 plus 1/3 is a little bit more difficult because I'm going to need to get a common denominator. So to get my common denominator, I would look to see, can I just multiply 3 by a number to get 5? And if I can't, the easiest thing to do is take my 5 and just multiply it by the other denominator. Multiply by 3. But if I multiply my denominator by 3, but then I have to multiply my numerator by 3. So I get 3/15. And then over here, I would need to look at that number and say, well, if I multiplied to get 15 as my common denominator, then this one I would multiply by 5 to get a common denominator of 15. And then we end up with plus 5/15. Okay? So if I rewrite everything again, there's my problem. I'm going to combine these terms together and actually add those two terms together to get 8/15, which means my answer is 10 and 8/15. A little bit easier than that first problem, huh? And then last problem. This one has decimals, it has a fraction, it has a integer or whole number. And this one, the answer becomes -8.75. So if you are correct, you have finished the video. Otherwise, let's go through this question together. To start off, I would look at each of my values and say, well, this one is a decimal and this one is a mixed number. Can I rewrite this piece of the fraction as a decimal value? Okay, and the answer would be yes. 3/4 is the same as 75 cents. Or in this case, I would get 4.75. And so what we can do is rewrite this problem in decimal form, which means we won't have to worry about common denominators. I do notice here that there is one subtraction, so I'm going to use the additive inverse property and change my subtraction of 11 to the addition of -11. And then I'm going to copy down the rest of my values, which were -2.5 plus 4.75. And here's a problem where I think the scoreboard strategy would be really helpful because I have a lot of values. And so the scoreboard strategy says if we were to consider positive and negative two teams, we're just going to look at the scoreboard to figure out who's winning. And the way we do that, 2.5 are points that the negative team has. 4.75 are points that the positive team got. And then the negative team also has 11 points here. And so first thing I would say is, oh, on the scoreboard, I need to know how many points each team has. Well, the positive team has 4.575 points, and the negative team has 13.5 points. So then I ask myself, well, which team is winning? The negative team is winning. By how many points? So don't think of this as a math problem, but just like a scoreboard, we want to see which team has more points and by how many, right? So when you look at a scoreboard, we always want to look for the winner and by how many they're winning by. So if I was thinking of this as just a scoreboard, I would say to myself, well, I know that the negative team is winning, and if I wanted to know by how many points, I would subtract the difference, subtract from the 13.5, 4.75. I'm finding the difference between the team's points. So in this case, let's see, I would need this to become a 4, and then 10 minus 5 is 5. I need this to become a 2, so I can regroup to 14 minus 7, which is 7. And then I can just say 12 minus 4, or I can regroup again and say 12 minus 4 is 8. So 8.75, but remember the negative team won, so -8.75. Okay?